Hello and welcome to this higher tier GCSE lesson on spheres. Firstly, complete this do now task. Calculate the surface area of the cone. Write down all your working. Okay, pause the video while you work through the question. Okay, let's check the answer. Remember that the surface area formula is pi RL plus pi R squared. And you can see the substitution, and the answer is 84.8 centimetres squared. So we're going to be looking at the volume as well as surface area of spheres and then apply these to problem solving questions. So here we've got a sphere. It's very hard to draw that on a two-dimensional picture. We can see we've got R as the radius of the sphere, so from the very centre of the sphere to the edge. And the volume, we're going to copy the formula for the volume into your books, is 4/3 pi R cubed. So an example, we've got a sphere of radius 8 centimetres. We're going to copy the question and calculate the volume. So we're going to work out 4/3 times pi times 8 cubed, and that gives us 2,140 centimetres cubed, and that's been rounded to 3 significant figures. You're going to have a go at some of these. Make sure you write down your working as well as the answer. Pause the video while you work through them. Okay, let's check these answers. So the top row, you can see the values. They are all rounded to 1 decimal place. Since it doesn't say what type of rounding you need to do for your answer, it doesn't matter if you've chosen different rounding to this. All of your answers should have centimetres cubed on them. Okay, before we check the answers for the second row, just notice that this is the diameter that you're given, not the radius. So just double check your work. If you've used that value as the radius, go through them again. If not, well done. And these are the answers. And again, just mark those nice and quickly. And that final row, just make sure that once you've worked out the volume of the sphere, you've halved that because you've got a hemisphere. Okay, let's check those. And like I said at the beginning, all of those values should have centimetres cubed. And if you've done different rounding, you've done significant figures rather than 1 decimal place, that's absolutely fine as long as your rounding is accurate. So now we're going to have a look at the surface area. So the formula here is 4 pi r squared. And I reckon you can go straight into those questions. You've got the formula up there. You're going to substitute the value, show the working. So for the first one, you will write 4 pi times 5 squared. Okay, make sure you write the working as well as the answer, and pause the video while you go through these. Right, let's check the answers. So these now have units on. So check the values. Again, they are rounded to 1 decimal place, but if you've done different rounding, as long as your rounding is accurate, that's fine. Again, with the second row, you're given diameter, so make sure you've halved that value to get the radius. And then we've got these values here, so mark those ones. And finally, for this last row, if you've just halved the value, that is not correct. Make sure you've included an extra circle for the base as well. So you've got the curved part and the base. So if you've not done that, go back and work through these questions again to correct them. Right, let's check those. These are the values that you should have. So if you need to pause the video to finish any marking, then do that. Again, like I said at the beginning, if you've done different rounding, that's absolutely fine because it wasn't specified in the question. Okay, some quickfire questions for you here. Pause the video while you work through them. Okay, answers then. Question 1 is 36 pi centimetres cubed. We've got 288 pi centimetres cubed and 1,330 pi centimetres cubed. Do make sure you read the question carefully, as both question 1 and 2 have told you to give your answer in terms of pi. Okay, so the answers for question 2. We've got 36 pi centimetres squared, 100 pi centimetres squared, and 196 pi centimetres squared. Question 3, we're given the diameter, so just check carefully there. The volume is 65,400 centimetres cubed, and the surface area is 7,850 centimetres squared. Question 4, we're told that a solid sphere fits exactly into an open cubical box of side 25 centimetres. If it fits exactly, that must mean that the widest part of the sphere is the same width as the box. So the diameter is going to be 25 centimetres. So using that information, they've rounded to 3 significant figures here. We've got 1,960 centimetres squared to 3 significant figures. Hey, some problem solving questions for you. Pause the video while you work through these. Okay, question 5, let's check the answer. So the first thing to do is work out the volume of that sphere. You know then the cylinder is going to have the same volume as the same amount of metal. If you know the radius and the volume, you're able to calculate the height, which is going to be 125 centimetres. Question 6, we're given a density, and we're given the radius, and we're given a weight. So firstly, we're going to need to make the units consistent. That was a hint at the bottom. So if we convert our millimetres into centimetres and work out the volume of one sphere, convert the kilograms into grams, and then we're going to find out the number that we can make, which is going to be 6,232. Question 7, we've got a sphere of radius 5.0. It's got the same volume as a cone that has a radius on the base of 8.0 centimetres. So first of all, work out the volume of the sphere, and then using the radius and the volume, you can work out the height of the cone, which is 7.8 centimetres. Okay, another question for you here. We're just going to have a think about this one. I'll pause the video for you to read it and have a think about your answers. Okay, so what we've got then is that a standard football must be between 68 and 70 centimetres in circumference and between 410 and 450 grams. We're told they're usually made up of 32 panels, so that won't be a perfect sphere, but for the purposes of our calculations, we're going to assume it's a spherical shape. So will the football manufacturer be more interested in the surface area or the volume, and why? Well, it will be the surface area because that's the amount of material that's needed to make the ball. And therefore we want the least amount of material so they can make the most amount of money on this. And the variation, well, if you're given the circumference, you can work out the diameter. If you've got the diameter, you can work out the radius and therefore the surface area. So using the 68 centimetres for the first value and the 70 centimetres for the second value. So although the diameter doesn't vary much, the surface area and the amount of material needed can have quite a big difference. Okay, so some more problem-solving questions for you to have a go at. Pause the video while you work through these. Right, so the first one, question 9, we've got a sphere and a cube. We need to work out the volume of both of those. If we find the difference, we can find out how much wood is wasted. Then if we do the wood wasted out of the full cube and convert that into a percentage, we get 48%. Number 10, we've got a cylindrical packaging for a sphere. The curved surface area of the cylinder is made from card. We want to show that the area of the card is the same as the surface area of the sphere. This is going to have to use algebra because we're not given any specific values. So if we take the radius of the sphere, which is also going to be the radius of the base of the cylinder, we call that r. The height of the cylinder will be the height of the sphere, so that'll be 2r. And the curved surface area, remember the circumference multiplied by the height, so that's 2 pi r times 2r, which gives us 4 pi r squared. And that is the formula for the surface area of a sphere. So well done if you got that one. Okay, so we've looked at the volume and surface area as well as some problem solving questions. We'll just finish with this final question. Pause the video while you work through it. So the answer is below. We can see here the volume of the hemisphere is 144 pi. Since the volumes are the same, we can say 4/3 pi r cubed is equal to 144 pi. That means we can cancel the pi's out. Then solving that, we've multiplied by 3, divided by 4, and cube rooted. So you've got the cube root of 108 for the radius of that sphere. The surface area of the hemisphere, we've got the curved part, and we've got the circle on the base, and that gives us 108 pi. The surface area of the sphere is 4 pi times by the radius squared, the radius that we worked out before. Once we've got those values, we can calculate a difference using your calculators, and you should end up with 54.3 centimetres squared. Okay, that is it for this topic. If you haven't already, you may want to have a look at the challenge topic of frustums. Otherwise, you will now be moving on to the review questions. Okay, well done and goodbye.